Yeah, so now in this presentation, we would be starting with Proteus. So Proteus is a highly advanced software used in a lot of industries and used by a lot of electronic enthusiasts and hobbyists. Proteus has many applications, like we can use it to make schematics. Like schematics are the circuit diagrams which you make. We can design PCBs, like printing it on boards and physically making the circuits. We can simulate them. We can import third-party modules and many more. So yesterday we had given a link, a drive link where we had the Proteus exe file. So have you guys installed it?
No, भैया.
Um,
Yes,
like,
yes, absolutely.
okay, so like those of you haven't like installed it, you can like do it now. So like we would be going step by step, and like when I'll be explaining, we would be making the circuit, writing the code and simulating it. So I want all of you to follow along with me.
Can you reset the code in the group, please?
The drive link.
Yeah.
Okay, I'm sharing the drive link in the MS Teams chat.
Okay.
So you guys, okay, I've sent it. So open up the drive. You'll be finding a exe file like this. Okay, it's around 500 MB. You can like download it and you can install it. Just the installation process is very simple. Okay, so like on the table of content, briefly is that we'll be touching upon some of the basics of Proteus. We'll be looking into certain modules, how to import them in Proteus and work with them. We'll be looking into a turtlebot and simulating all these. The basics of Proteus. So you guys, so when you open up Proteus, you would have something like this. Can you see this window?
Yes, भैया.
So if like we will be having certain like documentations on the sides, like the projects lists and all these. So we'll be going one by one and looking into all these. This is some glimpses of the SDV bot that we made in the SDV 2.0, like in physical mode. So in that board we use certain components like the Arduino Uno, the servo motor, the ultrasonic sensor, the motor driver, IR sensor, DC motor, and the power bank. So you can see a picture over here. So we would be taking these modules, all these components one by one. I'll be explaining the circuit, making the code and simulating it. And after all of these, we would be compiling all of them together to make this bot. And we will be running it on a track. Okay, so I would like you all to follow along with me. And if you have like face any doubt, you can unmute yourself and say, or you can write it in the chat box. We'll be starting with the IR sense. Like the theory portion of these sensors was covered in the earlier PPT and yesterday. So I won't be focusing on the theory. I'll be focusing more on the simulation. Okay, so if you go to the drive link, you'll be seeing a infrared sensor library folder over here. Okay, so if you open this up, you'll be finding some files. Okay, so I want all of you to download these files and then right click on the Proteus icon, go to the file location, go to this Proteus 8 professional folder, open it up, go to data, then go to library, and then paste the files over here. Okay, and then after you have pasted it, you restart Proteus. So please do that, and if you face any problem, then please tell me. Okay.
Dada, all that other files you have to paste here, right?
Yeah, all these. Okay, so let's do it all at once. Go to the infrared sensor library, download all the 4 files, then go to the Arduino library, download these 2 files. Same for motor driver and same for the ultrasound. Okay, download all these files, keep it together in one place, and then go to this directory and paste it all over here. Okay, so this is the path. Proteus, go to the Proteus file location. I'm showing you once again the icon. So you right click on it, go to the file location. So Proteus 8 Professional, open it up, go to data, library, and then paste all these files. Okay, and then restart Proteus. Cool. So let's start. So when we open up Proteus, you start a new project by clicking on this new project. Okay, so you can give any name. Click on next. So we can like select a default schematic template over here for now. Okay, so I'll go a bit slow. Okay, if you have like imported the libraries, just um, tell me. Okay, like if you're facing any issues or. So the drive link is provided in the chat and also in the WhatsApp group yesterday. Um, just go to these folders. There are 4 folders on top. These are the modules. Open it up. Download all these files. Okay. Download all these files and paste it in this directory.
Dada, there is one file called infrared sensor simulation. That one also you will paste in the library. One file which has one icon. Others do not have any icon, so I was asking that.
This one here, yeah, paste all of them.
Okay, okay.
Okay, I'm like waiting for 1 minute. If after you're done, just tell me. Okay. So again, repeating, go to the drive link, open up all the 4 folders, download all these files, all of them.
भैया the
Yeah.
TEP ILB file, is that a zip file?
This one is SDV.
No, in the infrared sensor library. There's a last 2 file, the last file.
Yeah.
It's a zip file.
Just download all of them and just paste it in that folder. You don't need to extract or anything.
I got it downloaded in a zip file. These 2 only. All the other are in document.
Like the extension is in .lib, right?
extension.
Would you like to share your screen? Then I can like have a look at it.
Yeah, yeah. But I don't have a permission for that.
Just a minute. Do you have access now?
No.
Okay. Do one thing. Um, okay. See, just don't extract any file or anything. Okay, just download all this as it is. Okay, and just keep it in one place.
Okay.
Now open up. Now go to your Windows. You'll find the Proteus icon. Can you see it over here?
Yes.
Right click, open
Open
file
file.
location. Okay, and then click on this Lab Center Electronics on top. Then open up Proteus 8 Professional. Go to Data, Library, and paste all these files.
Data. Okay, all the files.
Yeah, once again. So after you have downloaded the files, right click on the Proteus icon, open file location. Again, then click on the Lab Center Electronics option on top. Open up this folder. Open up data, then library, then paste.
Done भैया.
Okay, cool. So after this, after this is done, restart Proteus.
Okay.
So after you restart Proteus, click on New Project. Give it any name you want, any path of location, and click on Next. For now, you don't need to select a template for the schematic. Just go with the default schematic. Click on Next. For now, we do not need the PCB layout. Just click on Do not create a PCB layout. Click on Next, and also No firmware. Click on Next. Finish. Then we would be having a workspace like this on our screens. Is this much done?
Good new projects and Default.
Like for schematics, you have to select default option, right?
Yeah, default.
No form field. Which form field product project we have to create? Flowchart or firmware?
And do not create PCB layout.
Okay, look at this. New project, go to
Mm.
next,
Mm.
uh, default
Mm.
schematic, click on next, do not create PCB layout. Okay, click on next, no firmware. Click on next, then finish.
Okay.
You will have a schematic workspace over here opened. Done?
Yes. Yes, we have.
Okay, cool. So see, this is the workspace for Proteus. We have various options at the sides where like we would be importing components, various tools and all. So this is this yellow icon over here is the components icon. Can you see component
Yeah.
mode?
Yes, we have.
Yeah. So over here, when you click on this icon P peripherals, you get all these a list of various devices. Okay. Can you see Arduino over here
Yes, we
in
have.
the list? Okay. So this is the Arduino. Double click on the Arduino, so you'll see that the Arduino gets listed on the side over here. Okay.
Hmm. Done.
And now go to, let's search IR sensor. Search IR sensor, you'll get IR sensor like this. Double click, again it will be listed on the side. Done.
Done.
Mm. So for the first module, we will be just looking into the IR sensor. Okay, so click on the Arduino Uno, come to the workspace, left click, you'll get the Arduino over here.
Yeah, got it.
Prashant was asking what after clicking next. Next as in the when we are creating a new project over there. So like after next, just click on next. We just use the default schematic. Then we go on to the no PCB. Then click on next. Then we don't need any firmware, no firmware. And then click on next and then finish. Okay. So the IR sensor also pasted over here. So paste these two over here. Okay. So, like, how do you navigate around in the workspace? We can use the mouse roller to zoom in and out. We can click on the roller button, then we get something like this, and you can just move your cursor around to like go to some place and navigate around in the workspace. Okay, so let's make the connections. So the IR sensor have these three major terminals, the output, ground and VCC. So we are going to go to the this terminals mode on the left hand side panel. Click on terminals mode. Okay. You will find something called ground over here.
Yes, we
Click
have.
on ground, paste ground over here. And then make a connection from the ground to this ground terminal.
Can you show that ground portion? I am not able to do it.
Yeah, there's a terminals mode. On the left hand panel, can you see it?
Yeah. Then
Click on it, you'll see ground over here. Ground. So click on ground and click on the workspace. You will get uh, the ground
Symbol.
thing on workspace. Okay, and then make the connection from the ground terminal to this component ground. Yeah, Prashant. So there's this component mode. Click on component mode.
I am not able to make that connection. Like it's going along with the mouse that wire.
Yeah. So
Click
like
it.
see, paste the ground component over here. Go to the head of the terminal. Left click. Come back to this terminal and left click again. Like this, will make the connection. So same for the power. Click on power. Put it over here. So like when we are making these circuits, we can like rotate the components. Okay, so you can press the plus plus on the keypad or the negative on the keypad to rotate it. Okay, and then from the VCC I'll
Can you
connect to
repeat that
the,
rotation part?
yeah, okay. So the power, left click, you'll get the power over here, and then click on the plus button on your keypad, on the number keypad on the right hand side of your keyboard, on the plus button, plus or the minus button. So that will make the component rotate.
Done.
Okay.
Actually, in my laptop, I do not have that number pad. I have that, on that symbols. That so in that case, I cannot
You
do that.
can just click on the right click on it and just rotate it like this also. Okay, so we'll make a connection from VCC to power.
Done. Yeah.
Okay,
Dada,
so
I'm facing one problem. That power is having means upside. It's not going. Means I'm not able to make it downside.
Paste it and right click and turn it 180 degree.
yeah, you can like turn it 180, like right click and turn 180 degree. Okay, so that was the circuit, and then now what we want to do is that we want to detect the output of this IR sensor to the from the Arduino. So let's connect output with pin number 2.
Uh, Sorry to interrupt, but it is creating another power source with 180-degree one. It's creating actually two power source. Sorry to
So
interrupt.
Uh,
delete the
uh,
previous one.
yeah,
Okay.
like you can press Ctrl Z to undo if you have created one more component. Or you can right click on the component and delete object like this. Okay, so like connect the output to the pin number 2 on the Arduino. Okay, and like when we are Actually, when we are doing this in the physical mode, what happens is that we are detecting a physical object. So over here we are not getting a physical object on in this simulation. So the Proteus provides us with an extra pin called test pin. So we can actually like manually say what type of like whether there's an obstacle or not. So we can control the like external signal from this test pin, and then we can get the output in this Arduino. Okay, so this is the schematic. So for the test pin, what I want you all to go to the devices, the component mode again, click on PP, then search logic state. Search logic state, you will get something like this. Double click, paste the logic state over here, and make the connection with this logic state component.
Which logic state? There are 4 logic state. Large origin, large source.
Logic state. So it would give you something like this, a single logic
Latch
state.
function.
Yeah,
I
latch
have 4.
steps.
I have 4. So
So use this one.
where to put it?
So paste it on the side where you have the test pin, and then make the connection with the test pin.
Okay. Done. Done here.
Okay, so this is the
Bhaiya, show
schematic.
the logic
Uh,
again.
Yeah, okay, go to the component, click on P, search logic state. We will get this latched action logic state source. Double click on it, and you will get the logic state in the devices panel, and then paste it in your workspace and make the connection from the test pin to the logic state. Right, so this is the schematic. So let's go with the code. So open up the Arduino IDE. When you open a new project, you will get something like this. Void setup loop. These were covered in the earlier presentation, so I won't go much into the working of it. So let's set up. So we had connected the output to pin number 2. Okay. So we want the Arduino to take input from the IR output pin. Okay. So let's write pin mode to input. So like as we know that the IR sensor gives you like a digital output. Okay, it's either 0 or 1, high or low. See, when you are looking into certain modules, you will come across the term called data sheet many times. Okay, data sheet is something. So this is the IR sensor data sheet. Dataset is a like a PDF document which actually gives you a lot of information regarding that module, like the the voltage rating, how it works, which what is the maximum voltage for each pin and all that in internal circuit and all, right? So it gives you a digital output in Arduino. So we would get either 0 or 1. Okay, so we'll go to the Arduino IDE. We'll create a variable result equals to digital read. So digital read will give you the output from this pin number 2. So let's create a conditional statement. If result equals to 1, okay, right. So how do we detect it? Yes, sorry, so I will connect an LED over here. Okay, so if an obstacle is detected, I want an LED to glow up. Okay, so let's go to the component again. Click on P. Active LED. So it's active LED. Click on any LED of your choice, green, pink, purple, blue, anything. I'll go with this green one. Let's write, paste it over here. Okay, let's connect pin number 13 with this LED. And then go to the terminals mode again. Click on ground and make this circuit like this. Is that clear?
Yes, भैया.
Okay, so this is the so we want when the obstacle is
भैया
yeah.
which LED to select?
Click on any like LED, like green, blue, red, anything you want.
Can you show the codes, भैया, again?
The LED part.
No, codes part. Code.
Okay, so the schematic is done.
Yeah.
Okay, so let's go to the code. So when we click on the digital read and when we get a result of 1, so when we get a result of 1, we want the this to be this pin to glow. Okay, so we want the pin number 13 to be the output. So we will write pin mode 13 output. Right. Then, so if the result is 1, we want digital write 13. Else digital write 13 low. So this is the code. So is this code understood?
भैया show the LED part again.
Yeah. Go to the components mode. Click on P. Search active LED. You will get a list of LED. Click on any LED of your choice and paste it over here and make the connection like this. So this is the code. Okay, so to like the we to connect the Arduino code from the IDE to Proteus, we need to do something. Click on File, go to Preferences. You will find the option over here, Show Verbose Output During. Okay, uh, check on the compilation option over here. Again, go to the File, Preference. You will find Show Verbose Output During and check on compilation. Right. So after the code is done, we would not be uploading it. We would just verify it like this. Just click on verify. We'll get a highly verbose output.
भैया, there is disturbance. There is lot of.
With, or yeah. So after clicking on file, go to preference, click on this compilation option on the show verbose output during. Okay, check on this compilation part, and then just verify the code. You will get a highly verbose output in this terminal. Okay, then what I want you to do is you will get a path in this line .elf. I want you to copy this path. Go to Proteus, double click on Arduino. You'll get program file over here, okay? And I want you to paste the location like this. Click on OK. Understood?
Dada, can I again show the processor?
Yes, yes. So, like after click, so have you done the preference thing? What
Yes,
was
Bhaiya.
this?
Yes, Bhaiya. And
So
I,
after you verify, yeah.
I verified it, but it's showing input was not declared in this scope. Must have done something wrong.
Um, is the code right? Have you checked the code?
No, no, it's true. I think.
So we declare to digital pin 2 as input, digital pin 13 as output, then we store the result in a variable, and then we run a conditional statement like this. After it is done, just verify. So at the end, you will get a .elf file over here, a path. Just copy this whole path. Go to Proteus, double click on this program file, and just paste the whole path over here and click on OK.
Where to double click?
Double click on Arduino.
If a C user something path like.
Yeah.
Okay.
C user, yeah. On the third last line, you will get this path
Okay.
.elf.
Yes, I got it. Got it.
Yeah, then go to Proteus, double click on the program file, and just paste it over there.
And enter. Okay.
Okay, and for this IR sensor to work, we need a firmware also. So what we do is double click on this. Okay, we'll find a program file for this IR sensors. So I want you to browse, go to your location where you have
Edit
the
from where? From edit from where?
no, double click on IR
Yes, yes.
sensor. You'll get a program file over here.
Okay.
Click on this browse file icon over here on the right side. Then go to your Proteus file location. Okay, it's in C, I guess, program files, and then go to Proteus Lab Center Electronics, Proteus 8 Professional. Go to Data, Library. You will find your hex file that you copied earlier, infrared sensor tap.hex. Did you find it?
I'm not able to find my Proteus file.
I guess it's somewhere in your C directory where you have installed it. Go to the
See,
location.
program 86.
Then go to Lab Center Electronics,
Oh, lab
Proteus
center.
8
Okay.
Professional,
Okay.
then Data, then Library. Then you will find infrared sensors tap.hex file.
Yes, we are.
Click on it and select Open. So the directory would be pasted over in this uh, field, and click on OK. Right? This much done.
Yes, we are.
Okay, so that's over. So let's start with the simulation part. Okay, so see, this is you find a play button on the bottom left corner over here.
Yes, भैया.
Click on it, and you will see that the simulation will start running. Okay.
Yes, भैया.
So what happens is you click on this test test pin, the logic state. Click on it. It will be 1, 1, 0. We can just interchange it. So when it becomes 1, it actually means that there's an obstacle in front of the IR sensor. So what happens is that the output gets to the Arduino and the LED starts glowing.
Yes, भैया.
And you again click on 1, becomes 0. And then the LED will stop.
Yes, भैया.
So that is how like the simulation runs. You can click on this stop icon over here. So to stop the simulation. So that was about the IR sensor. So let's move on to the next sensor, the ultrasound sensor. So the ultrasound sensor.
भैया show the simulation again.
Okay. So you click on the play button on the bottom left corner. Then click on the logic state. This will make the LED glow.
Okay.
And click on it again. You may wait for some time if the CPU load is high, and then it will stop the LED from glowing. Then you can stop the simulation by clicking on the stop button. Right. So let's move on to the next sensor, that is ultrasound sensor. So the ultrasound sensor, the working is like what happens is there's some pins. Like let's go to the data sheet. This is the data sheet for the ultrasound. It has various terminals like VCC, trigger, echo, ground. Okay, so what is the working behind? How does it work? So the working is simple. What happens is that we need to send a 10 microsecond a 10 microsecond pulse from the Arduino to the trigger pin of the ultrasound sensor, which will make the ultrasound sensor like know that we want it to detect. So after that, the ultrasound sensor will.
You are muted, भैया.
Yeah. So like after the trigger pin, like we need to send 10 microsecond pulse to the trigger pin of the ultrasound sensor, and by that the ultrasound sensor will know that we want it to emit waves. So after that, it's gonna send 8 pulses, and then after that the echo pin will wait for the signal to come back after reflecting from an object. And what happens is the echo pin would give you the time in microseconds. So can anyone tell me why do we use a pulse like this? Like we can just use, like why do we use 8 pulse? We can just straight away send 1 pulse and then get the signal. Any idea?
Like so that we can, if there is any by chance we cannot get back one pulse, so might not be right.
So obviously the object is moving. The car, the bot is moving. So we have to send more than one so they can uh, uh, apprehend the where it is it going or where the
Um,
obstacle is.
okay. Any other answer? Like whatever you think, you
भैया
can
to
just say.
avoid
Maybe wrong. Yeah.
भैया to
Yes.
avoid superposition.
Um, okay, so the reason that we see all of you are not exactly to the point where we are using the this 8 pulses. The reason that we are using 8 pulses, actually it is the internal working is such that we want 8 pulses so that we differentiate ultrasound sensor signal from the rest of the surrounding noises. Okay, so 8 pulses acts as a unique key to detect that this is the signal from an ultrasound sensor that is coming, because from ultrasound sensor can have a lot of frequency, a lot of noises in the surrounding. Okay, so we emit 8 pulses of very high frequency to like differentiate ultrasonic wave that this sensor emits from the rest of the surrounding noises. Okay, so that is why we use this.
Dada, can you share the links for these two datasets in the chat?
Okay, I'll share this one in the MS Teams chat, right?
Yeah, yeah, yeah.
This is for the IR sensor. Yeah, so that is how we use it. So let's go with the code. Okay, so let's start with the schematic first. Let's see. I will go through each and every sensors. So let's go to you go to the drive link. You'll find a sdv.rad file over here. Can you all download this? You will have all the link to all the schematics over there.
Yes, we are. Yeah,
Just
found it.
download it and extract it. Okay. So so we won't okay. So go to the drive and download the sdv.rad and
Yes,
extract
I'm
it.
fine. Yes.
You'll find it over there. So open up the project that says ultrasonic sensor and open it up. Okay, you'll get a schematic like this. I'm sorry if there's any background music there. Um, so you can open up
Which
the schematic.
which
Yeah,
project we have to open via?
ultrasonic sensor.
Ultrasonic. Okay, we have. But yeah, it shows in order to load project, you must use Proteus version 8.13 or later. I might have the older version of it, 8.1 version.
Um, that may be an issue. Let's then we can do something. You can just make the schematic from here. Just click on the component mode. Click on P. Go to search ultrasonic. You will get the ultrasonic sensor. You have the Arduino. Okay, and what else we need? We need a potentiometer. Click on pot. Click on pot, then you will get a potentiometer like this over here. We have. So we just double click. You will get it. Okay, and we need to make a circuit.
There are two port, three actually. There's active port and there's active port with a high granularly integrated
Yeah, just
potentiometer.
click on this one, which has no description.
Okay.
Yeah, so you click on that and then um for so what we do is after that just okay, so connect your pot over here and then connect the test pin to the this terminal of the pot where you have the arrow, and then connect a ground over here. Okay, and we need a power source also. So click on this generator mode. Generator mode on the left panel. Can you see it? Generator mode over here. It's like a icon of a sinusoidal curve. Click on it. You will find DC, the DC power source, and then make the connection to this potentiometer. Yeah, I'm not going much into the ratings of how much voltage we need. We can just click on any like anything you need. Just click 10 or 100 or whatever. It's up to you. When you're designing the circuit, you can just calculate all the values and then accordingly do it. So make this circuit potentiometer power source ground. So now what we need the echo and the trigger pin. We don't need to connect the 5 volt and the ground because Proteus will like it doesn't make any difference if you're connecting it in this workspace. But in real life, you need to connect it to the power and the ground. But for simulation purposes, Proteus makes the circuit a lot simplified, so some of the pins can be ignored. Right. Click on the echo pin connected to digital pin number 3. Connect trigger pin to digital pin number 2. Right. Is this much done? Okay, so let's move on. Okay, I'll open up the code for the ultrasonic sensor. Okay. Okay, so when I was talking to you about the working, so first of all, let's define these two pins. Here, defining these two variables over here. You know, when you're defining the pin number, just have a look at the schematic ones where you're connecting the echo to the which pin. Echo to in my schematic, I'm connecting echo to pin number 3 and trigger to pin number 2. So same thing over here. Define this over here. Would you like me to give you the code over here? So let's not to spend much time on typing it.
Yes, Bhaiya. And I'm still not able to that IR that ultrasonic sensor. I'm not able to get it.
You're not getting the ultrasonic sensor in the components.
No, Bhaiya.
Is anyone else having the same issue? Or you've completed the circuit?
Ultrasonic sensor.
I'm
There is
having
one
an issue.
ultrasonic sensor pre-made. Can I paste it over here?
Yeah, yeah, sure. Like, does it look something like this? The
Yes, Bhaiya.
engineering project. Yeah,
The
that is.
engineeringproject.com.
Yeah, yeah, that is the library which you imported earlier. So that's the exact
Okay.
ultrasonic sensor. So just paste it on the workspace and make the circuit like this.
Here is ground. And what is RV1?
Sorry.
Top of that RV1 to the what?
Yeah. So what happens is you click on this device, search port. Port will get your potentiometer over here. Click on this normal one default which has no description. Just double click and you'll get it listed on the side. Paste the potentiometer over here. Connect it to ground. Connect the test pin with the potentiometer arrow terminal. Where you have the arrow.
Oh, okay. My arrow is in the middle, actually.
Yeah. So you can just, yeah. It doesn't matter. We can just change it plus and minus and change the arrow. Also, click on the test pen and connect it with the arrow terminal and just go to the generator mode option on the side. At the left panel, you'll find generator mode.
Hmm.
Click on DC.
Hmm.
This is the DC power source. So create a DC component over here.
Done.
Okay, I will upload the code over here. Just a moment. The SDV code will be in a RAR file in this drive. Okay, just download all the code from there.
Can you show the connection between the Arduino and ultrasonic sensor?
Yeah. So Arduino, we need to connect the echo pin and the trigger pin. Just click on in my schematic. I have connected echo to pin number 3 and trigger to pin number 2.
Okay.
Okay, so that's the schematic. If you have the
That
code, I have.
DC one I am having some problem. DC one, can you please repeat?
Yeah, go to this generator mode on the left panel. Click on this generator mode. You will find DC on top.
Yeah, okay, thank you.
Yeah. So this is the circuit. You can download the code from this drive. Okay, I have pasted the code from there. Open it up and you will get the RAR file. Or under it, you will get the ultrasonic sensor code. So open it up. Okay. So this is the code. So as I said, you know, the working is such that we need to send 10 microsecond pulse to the trigger pin. So what happens is that we write digital pin. Okay. So this is like we are clearing if there's any like noise or anything in that pin. So we click right low over here, and after that we send the pulse to the trigger pin in this line, and then we wait for 10 microseconds, as I said in this demonstration, in this diagram. So we send the pulse. After 10 microseconds, we set the pin value to low. Okay, and then after we have sent it, what happens is the ultrasonic sensor will detect this 10 microsecond waves, and it will automatically send these 8 high frequency pulses towards the obstacle what we have in the front. So after that, we need to wait for the signal to come back. So what happens is the echo pin will give you the output in the form of microseconds. So so after this, we will be like defining this variable and we'll be storing the pin over here. We will be storing how much value we have. So all these things were like, I'm not going much into detail of the working because these were explained in the earlier theory. Okay, so I'll just go through. So this formula was also set. So like how much time the sound wave can travel in one. This is this centimeter, how much time sound wave can travel in 1 microsecond. So we are like finding the distance and then dividing it by 2. So you do the same thing, verify it, copy the file path, double click on program, click on this program file. Okay, so we want the output to come in the serial monitor. What we can do is that go to the virtual instruments mode on the left panel. Can you see it? It's on the left panel, virtual instrument mode. Click on it. You will get a virtual terminal over here.
Yeah, after code, we have to copy the same path over there.
Yeah, same. For
In the
all the modules, yeah.
ultrasonic. There are two
Yeah, for
parts.
all.
They are showing two path.
In the Arduino.
In the code, I run the code. There is showing two path actually. There is C program files, Windows app one, and Arduino IDE, and there is C user and my local file one.
Yeah, you need to click on the C user this file where you have the .elf extension at the end.
Yes, we are.
Yeah, so just copy the path.
Okay.
Go to the Proteus um, and double click on Arduino and then paste it over here. Program file.
Okay.
Right. And similarly, what we did in the IR sensor, click on the ultrasonic sensor hex file. The ultrasonic sensor hex file can be found in the same directory where you found the hex file for the infrared sensor. Okay, click and open it up. So you'll get the um, library location.
Dada, one question to ask. If we have
Yeah,
to change anything in the code, then again we have to do that same process of pasting that location, right? Or will it be automatic? Like
no,
suppose here I have to make some change.
the location will be automatic. You just paste it once, and the changed when you re-verify it, the changed code will be compiled in the same location. You can just rerun it over here. It will just automatically change. You don't need to again copy and paste.
Okay, thank you.
Yeah. So as I was saying, we need to see the output from the terminal. So we click on the terminal. You'll find virtual terminal over here. You click on this option virtual instruments mode at the left panel.
Yes, sir.
Click on virtual instruments and paste it over here. Okay, so we have two terminals on the output, I mean the Arduino, that is TXT and RXT. This is a transmission, the transmitter and the receiver. Okay,
Yes,
so
sir.
we need, so like what happens is that Arduino sends signals to the serial monitor. Okay, so we need the transmitter to connect to the receiver of the serial monitor. The serial monitor is receiving from the Arduino, and the Arduino is sending or transmitting. Okay, from the transmitter connect to the receiver. Same from the receiver of the Arduino connect to the transmitter of the terminal. Like this. Okay.
Yes, sir.
So that goes. So when we run the code, you will get a terminal like this, which will show you the distance. Like as we were writing in the code, serial dot write serial dot print distance like this. So the distance would be over here. Okay,
Bhaiya,
so if yeah,
Bhaiya,
go on.
that VSM debugger comes up. It's showing fatal simulation error encountered.
I think you did not set this hex file properly. Have you set it properly?
The program files, okay. Oh,
The ultrasonic sensor hex file also. You need
okay,
to do it for both the modules.
okay. We have to put the ultrasound, the path in both of them.
Yeah, like go to the same path. Yeah, for the program, for the program, what you need to do is copy paste the program path to the Arduino program file over here.
Yes, भैया.
And for the ultrasonic sensor, you need to go to the location where you have the ultrasonic sensor hex file. It is inside the library folder of Proteus where you copied all the files from the drive. Okay, and then you open it up.
Delete. Data library. Ultrasonic. Okay. Okay. Yeah, it's running. Running.
Yeah, so like that you can run this. So how do we change the distance? You can just zoom over here and just click on the negative, positive, and it will change the distance. Okay, negative, positive, and
It's not changing from the code only actually. It's showing 4 centimeter always.
um, I think, see, in my code, I have connected echo pin to pin number 3, and I
Yeah.
have connected trigger pin to pin number 2 of Arduino. Is that right? In
Yes,
your
भैया.
schematic. Okay,
Yes.
and is the potentiometer value like 1K? Like you can experiment it with different values. I think that would like create more differences in the when we are changing the value in the potentiometer.
Yeah, it shows 1K.
Yeah, and the value for the power is 10 volts over here in my.
No, it's 0 from my 10.
Yeah, so change it to 10 volts
Mm-hmm.
and
Run
run it.
again.
And
हाँ, yes, भैया. Okay.
okay,
It's
so that goes for the ultrasonic sensor. Is anyone else facing any issue? Anything? Okay, cool. Let's move on. So motor driver, we so see when we are this mod when I showed you now we had this motor driver on the top to run the motors for the bot. Okay, so why do you think we use a motor driver? We can just connect it directly to the Arduino. Any idea? Anyone? So like
मीट
motor
में ज्वाइन
driver.
होना पड़ता. मीट का लिंक कौन सा है फिर? Document. Round 3. If you are for the form, only leaders have to fill. Okay.
Am I audible?
Yes, you are audible.
Okay, can you see the screen? The motor driver slide.
Yeah, you can see.
Okay, so the motor driver, what we do is that we need a motor driver to run high torque motor. Imagine that you are using a very high powered
फॉर्म हमें
motor.
भी फिल करना है.
Imagine that you're using a high powered motor. Let's say it has a very high voltage rating. Okay, and if you connect it with
अच्छा
Arduino, it
अच्छा.
will work because
ग्रुप में
Arduino
ओके.
runs on a very low power, and Arduino runs on a very low power. Like the output, as you can, if you look at the Arduino datasheet, it gives you like 5 volt on the pins. So we need a like a motor driver to run. Motor driver has some internal basic layout like this. It has a H bridge layout which has 4 switches. Okay, this is the data sheet. I'll paste it in the chat. Right. So like what we do is that imagine we have so the pins, the switches can be like on or off. So we can say on or off, high or low, 1 or 0. It all is the same. So like imagine if we have closed S1 and S4. So the motor would run in this path from S1 to M to S4 to the V. So that will be the path. And imagine if you want to like reverse the direction again. So what happens is that you open up all the switches and then connect close S3 and then S2. So it will be like this. So from V to S3 to M to S2 to V again. That will be the path. So this is a simple logic or truth table type to show you exactly how it works. So similar to this. Okay, so now let's open up the project in Proteus where we have the motor driver. Open it up, it will be a motor driver project like this. You'll find something like this. If you guys have opened it up, you can tell me if you're facing an issue, you can tell me your doubts also.
So for opening these projects, we have to download that 8.13 version.
Um,
Like
the
like which version are you using?
Okay, I think the version that I am using is higher than this one sent in the drive, I guess. Okay, so let's never mind. Let's do it again. You can just click on the component P over here. Just write motor driver. You'll get the motor driver over here. Okay, after this, I will do one thing. I will send you the download link for my version. Okay, so you can run the projects directly from there. So what we do is that in here we have these pins IN1, IN2, IN3, IN4. Okay, these are actually the pins which are corresponding to the diagram which I showed you. S1, S2, S3, S4. So these are the control pins that we use to change the direction of the motor. Okay. So what happens is that if you open up the code for this motor driver, okay, so this is a very simple one. We are having these 1, 2, 3, 4, like 2, 3, 4, 5. These are corresponding to these latches. I mean these switches. Okay, so these are the outputs. So we can set them as 1 or 0, high or low, like that. So imagine if you want the motor to turn in the clockwise direction, we need 1, 0, 0, 1. Okay, so the code is like this: 1, 0, 0, 1. We want it to turn in the clockwise direction for 1 second. Delay 1000 is 1 second. This much. And after that, we need it to turn in the anti-clockwise. So 0, 1, 1, 0. 0, 0, 1, 1, 0. And then we delay it for 1 second over here. Okay, so we run this. We paste the program file. The motor driver does not have any firmware to be installed, so you just run the code. So you can look at the driver over here. You can see the motor. See, it's running like clockwise for 1 second, and then after that it moves to the other direction. So that is how we run a motor driver using this. Have you guys understood any doubts? Okay, so let's go with the next one. That is a servo motor. So the servo motor, it basically works on the pulse width modulation to detect the angle. Okay, so let's Okay, if you guys are facing issue with the um, schematic, let us make a new project. Okay, we will make a new project and I will show you the schematic for the servo motor and the code also. So be with me. Okay, so let's go with this. Go to the components, click on P, search servo. You will get a motor like this where it has 3 terminals. Okay, double click. We need Arduino. Double click, got it. So paste the Arduino over here. The servo over here. Okay, and let us say that we want the control pin to be number 3, let's say. Connect it to the middle one. Okay, and we need a ground pin also, and we need a power. Um, or you can use a power from here also, right? So this will complete the circuit. Is this much done? Any issues? Okay, so let's. So after the circuit is done, we can open up Arduino. You can go to the examples folder. Over here, examples, you will find a servo option over here. You can just click on sweep. It would open up a sweep program for Arduino. This is like a Hello World program for the servo motor where we can test it out. Okay, so open it up. Let us verify it. Let us copy the path. Double click, paste the path in the program file. Okay, so we can double click on the servo. See, by default, you will get the servo is set up as minimum angle as -90 and maximum as +90. So let us set it as -180 and maximum as my +180. Okay, because in the code we are changing the position from 0 to 180. Okay, like this. So if we run the program, you would see that the servo. Okay, 1 minute. I think the pin is wrong. This is pin number 3. Okay, so in the code it is given pin number 9. So we would connect it to pin number 9. Okay, so this would run like this. You would see the plus 180 like this. What it's showing is the degree. Okay, so it's -181 plus 80 like this. Have you guys been able to do this? Any doubt?
One question: what is the difference between this servo motor and that DC motor one? Like, can you explain?
Like servo motor is like we can, let's say we can, like if you want the motor to be placed in a certain degree, we can't do it with a DC motor, right? We cannot like set it to be like we can't set the motor to turn to a certain degree and remain static in that. But in DC motor, when we connect it, it just only rotates. Also, servo motor, if you want, you can, you can like, um, I'll give you an example. Like, let us say We have RC planes. Okay, RC planes, they have a servo motor attached to the wing, which actually rotates the flaps up and down. So servo motor is used to, like rotate it either clockwise or anti-clockwise to a certain angle.
Okay, okay, understood. Thank you.
I would like you can look at the data sheet of servo motor. It would give you much more insight into it. Okay, let us. Okay, I will add one more thing over here. Okay, let's go to the oscilloscope. We'll go to the virtual instruments mode. Click on oscilloscope. Let us. This is the control signal. Okay, we will connect it to, let's say, A. So like the actually in Proteus we don't need to connect ground or anything because it is much more simplified. But in real life, when you handle with an oscilloscope in a lab or somewhere, you need a ground and a power source. So we write this. We get a oscilloscope data over here. Okay. So this is the pulse width. Okay, you can see the pulse width is changing. As it's changing, it is the servo direction is also changing. This is like a virtual oscilloscope, what you can encounter in the real life in labs. So this is where you can like analyze your signals. So as I was explaining in the theory, we can change the width of the pulse to change the angle in the servo. Okay, so that goes with the um, module. So okay, so let's go with the turtle bot. So I will just show you just the overview of how a turtle bot works. So Proteus gives you a option where you can actually have a turtle where the bot is similar to this one, where it has all the modules combined. So open up Proteus, create a new project, go to next, schematic default, do not create PCB. Over here, when you're creating a form of create flowchart project, click on create flowchart project and set the controller to be Arduino Uno and compiler to be Visual Designer for Arduino AVR. Click on next, finish. It will create a flowchart for the Arduino like this. So we click on right click on peripherals, add peripherals. We will have a lot of peripherals over here. We click on motor control. We'll find Arduino Turtle. We added over here. Okay. We added over here and we get all the various um, functions for the Turtle bot. So the bot gets automatically connected. This is the Arduino structure. The bot gets automatically connected to the Arduino. So this blue thing is the ultrasonic sensor. These black blocks are the motor. These three blocks in the middle are the IR sensors. Okay, so let us experiment something. I will just want the bot to move forward for 1 second and then move backward for 1 second. So this flowchart is similar to the Arduino IDE where we have set up a loop function. Okay, so click on drive. You can just drag and drop the drive over here, which would drive these two wheels forward with a speed of 255. This thing is the time delay. You drag and drop it to the loop. Let's say 1 second, or let's say 2 seconds. Similarly for drive backwards. Or let me use it over here forwards for 2 seconds and then backward for 2 seconds. Okay, so this is a simple logic behind this. So when we click on run, we'll see that it is compiling the bot, and after that you'll have a virtual simulation of a bot moving forward for 2 seconds. It will move backward for 2 seconds like this. Okay. Um, I will. Okay, so we have some projects regarding the bot. I will not go much into detail. We have another presentation after this. You can open up the. I'll just show you the working. Okay, you can open up the project SDV. You will find a obstacle avoidance bot. Open it up. You will find a flowchart. I'm not going much into details into the logic. You can ask me. You can connect with me in the WhatsApp group. I'll explain it over there. You just open that project. What we do is that we need to we go to MS Paints and we create a track. Proteus gives you a standard that we can detect an obstacle by using the red color. Okay, so we use a red brush. We make an something over here. Let's size. Just create a boundary. So the board will move inside this. So these are the obstacles. Something. Okay, I'm saving it. Map. Okay, so let's go to Proteus. Double click on the bot. You'll find the path obstacle map field over here. So you browse to the map that we created. Okay, and so now let us run this. So the simulation with the okay, just a sec. In the simulation, we had the what? I don't know where the window went. Okay, so when you actually run it, so it is simulating what happens is that the obstacle would be avoided in that map. Okay, and it would run and avoid all the obstacles, and it would like navigate through the space. And we have the similar thing for the line follower in this. So what we need to do is just create a line using a black color ink. You click on the obstacle map and just paste it over there. Yeah, so it is running. So let's drag and drop it over here. So it will like follow the line and just move. Okay, so that is the line followed. I will again go to the obstacle and run again if it is. So double click, go to the obstacle map. Mm, I think there's some issue with the path over here. Okay, so you guys can test it out. Just as I said, just make the map in raw, and then you can just paste the path, and it would run. You can go through the logic, and if you have any doubt, you can ask me in the group. Okay, so that goes with the Proteus bot. Um, so I have linked some useful resources. This is the engineering projects website where you can find many projects for Proteus, like over here, and you can download these and play around with it. And this website provides you with a lot of libraries for Proteus, so you can have all these and have a look at it. And this is a great website where you can look into the data sheets to understand various terminals, the pin configurations, and the internal architecture of various modules. Okay, so that was from the Proteus.